with Oscar class. That's my dad.
Our last topic in Chapter 3, which is part of Unit 1, is the idea of absolute values mixed in with our inequalities. This is an excellent opportunity to review what absolute value means and the idea of compound inequalities. So, let's start with a quick review of what absolute value means, both in terms of numbers and algebraically. Now, I have the statement, the absolute value of -5. We know that's going to equal a +5 because the role of absolute value is to strip the sign off of the number. Likewise, I can talk about the absolute value of +5 is also an assumed +5. And I don't need to write those plus signs there. If there's no sign, it's assumed to be positive. Now, where this gave us a headache, possibly as far as the algebra goes, is when we talk about it in terms of a variable. The absolute value of x is equal to, let's not stick with 5, let's change to 6. Now, what numbers can x be to make that a true statement? And as we recall when we solved this, we talked about the idea of splitting the two cases. So we would split this into one case where x is equal to a +6 and another case where x was equal to a -6. Now I know one of those two is going to be true. In fact, my final answer in this problem would then be that x is 6 or -6. The idea that I don't know for certain which value is going to fit. Either one will work. In fact, if I look here, -5 and +5 both will lead to a +5 result. That's why when I was dealing with absolute value by itself, I had to have my two split cases. I had to have the positive case and the negative case. Now, when we work with inequalities, this bit takes on a slightly different angle because it provides more opportunities. So, let's talk about this idea where I say the absolute value of x is going to be strictly less than 4. So, before we get into actually solving this, let's talk about numbers that would make sense on the number line that would fit in this space. So here's my number line. Let's mark off 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, what are some numbers on this number line I might throw in? Let's start with the number 0. Is 0 a solution? Make a little table here. 0, our number, and is that a solution? So let's start with 0. Is 0 less than 4? Yes. So that means it's a solution. Let's do 3. Is 3 a solution? Well, let's see, 1, 2, 3. 3 goes in here. 3 is less than 4. Checks out. How about 5? Is 5 a solution? Well, 5 is greater than 4, so that's not going to work. So we know 5 doesn't count. How about -3? Let's try a negative out. -3, stripped of its sign, becomes +3, which is less than 4. Checks out. 1, 2, 3, -3. Now, let's consider -5. Now, normally, if I were to give you guys -5 and 4 and ask you to assign which one was greater, which one was less, you'd say, oh yes, -5 is indeed less than 4. But when I strip the sign off, and I'm now talking about 5, is 5 less than 4? No. So here, when I plug in -5, -5, stripped of sign becomes a +5, which is not less than 4, not a solution. -5 is out. As I check more of these numbers and think about what's happening, I'm going to see that all the numbers between 4 and -4, but not including them, because it's only less than, not equal to, the numbers in between make this true. Now it looks like a compound inequality we've talked about. If you think about our compound inequalities, when I'm working between two barriers, I use the word and. So, one way I can write this inequality, I can take this absolute value off, I can split my two cases, like we're used to. And I can say, hey, x must be greater than -4, and it must be less than +4. Make that a little clearer. In other words, this statement here is now split using the word and. So whenever my absolute value is less than something, I'm going to be using the word and to create some compound inequalities. Let's take an example problem with that and see what happens. So here's one that's using the absolute value and less than. Now this problem is already solved for the absolute value. I don't need to do any other steps before I do my split case. Remember, our objective when dealing with absolute value is to work our way down until we have just the absolute value on one side of the equation. Then we're going to split our two cases off. Now, because we're talking about an inequality using less than, I'm going to use the word and as part of this. So my two possible cases when I split this are going to be x plus 2 is greater than -6 and x plus 2 is less than 6. This will now force my result on the number line to be between two brackets. I'm going to be forcing the x plus 2 to be residing between the 6 and -6. Now I just have to solve these guys. Subtract 2 from both sides of my inequality. And I end up at x is going to be greater than -8. And x is less than 4. Now, it's not optional. I need to make sure I'm keeping track of what I'm doing here. So first, I've got my split case, because absolute value has two possibilities. So that's the first thing I need to make a note of. Then, here, I subtracted 2 from both sides. Now, I'm not multiplying or dividing by any positive or negative, so there's no going on, no flips. Just the good old-fashioned get to an answer. Now I need to graph it. Let's see, -8, +4, there's 0. It's greater than, it's less than, it's ain't equal to. So I put open circles on them, and then I fill her in. There's the graph of my solution. As a last thought, I can also write this as a single combined inequality. -8 less than x less than 4. Those are the same statement, just said a slightly different way. This is, for example, the difference between saying, I would like to go to the park, and I'm going to go park. Actually, that one's not even inappropriate. But again, it's the same statement. It's just set up a little differently based on how you like to talk about math. Let's take a look at one more of these before we move on to situations where the word or comes into play. Now this inequality is a little more challenging because there's a few more things I have to do before I can get to my split cases and my graph. For example, the absolute value is not yet on its own. It's not isolated. So my first task will be to get that absolute value isolated. I'm going to do that by adding 3 to both sides. So my first step is to add 3 to both sides of my inequality. It's going to leave me 2 absolute value x plus 1 less than equal to 8. Now, I still have to get the absolute value by itself. So I'm going to divide both sides by 2. This is going to give me the absolute value of x plus 1 less than equal to 4. And there I divided both sides by 2. Now, a common mistake I see a lot of students still making is that they think that to get rid of this 2, they need to subtract it. Remember, if there's no indication of sign there, it's assumed to be multiplication. So your task would be to divide both sides by 2, not subtract it, not add it. I want to undo that multiplication. Now, I've isolated some absolute values. My next task is to split my 2 cases. I'm using less than, and as we said, that means I'm using the word and as part of my word. Less than goes with and. So now I can write x plus 1 is greater than or equal to negative 4, and x plus 1 is less than or equal to positive 4. Now something else to comment. Notice that for my positive case, I flip the inequality around. Whereas in my negative case, in my positive case, I do not flip the inequality. In my negative case, I do. One way to remember this is that whenever we multiply both sides by a negative, we have to flip the inequality around. So one way to remember how to set up this new 2 cases for absolute value is that for the negative case, I have to introduce a flipped sign. So I'm going to write split case for absolute value. It's more or less what I'm doing there. And now I need to finish it algebraically. Subtract 1 from each side. And I'm left with x is greater than or equal to negative 5. And x is less than or equal to 3. Which when I graph, there's negative 5, 3, 0, arrows. It's equal to, so fill her in, equal to, fill her in, and it's an and. So I shade the middle part. The split case is a little more tricky because of the fact that we have to flip the inequality sign around for one of them. Otherwise, these problems are identical to all the absolute value work we have so far. We've also talked about how to graph compound inequalities, so you can see the word and creates this thing with the borders on it. Now, let's talk about what happens when we introduce the word or.